This unit of study deals with climate and weather and their effects on crop production. Climate describes the average weather and its variation for a region over a long period. Terms used to describe climate include temperate, tropical, arid, or humid. Weather describes the short-term atmospheric conditions and includes terms like windy, rainy, hot, or cold. Although many factors are influential in determining crops and crop production practices for a given area, climate and weather are the overriding factors involved. The importance of climate can be illustrated by briefly examining the agricultural diversity of a region or country. In the United States, many examples of agricultural diversity can be related to climate. Because of the modifying effects of oceans on climatic temperatures and the warmer southern latitudes, cold-sensitive truck crops like fruits and vegetables are located in coastal states. Examples include California, bordering the Pacific Ocean, and Texas, Louisiana, Florida, Georgia, South and North Carolina that border the Gulf of Mexico and the Atlantic Ocean. For similar reasons, cold-sensitive fruit and vegetable crops are located near the shores of states bordering the Great Lakes, such as Michigan. Southern Florida has a warm subtropical climate and long growing season, which is conducive to sugarcane and citrus production. Mountainous states such as Idaho, Utah, and Nevada have high elevations with resulting cool temperatures and short growing seasons that limit crop growth and crop adaptability. Crops like cotton and peanuts and warm season grasses like Bermuda grass require the warm temperatures and long growing seasons that are present in the southwest and southeastern states. The influence of the Rocky Mountains also limit precipitation in states near the eastern border of the mountainous region. Irrigation and drought-tolerant crops, such as sorghum, and drought-escape crops, such as wheat, are common in the Great Plains states, stretching from Texas in the south to North Dakota and Montana in the north. The north-central states, such as Iowa, Minnesota, Illinois, and Indiana, are well known for corn and soybean production. It is a region where cold, dry air masses from Canada meet warm, moist air masses from the Atlantic Gulf, resulting in the unpredictable and notorious thunderstorms of the Midwest. The next topic for study is the section on Profile of the Atmosphere. You should now stop the VCR and study this section in your text. Then return to the VCR for further tutoring. The outer reaches of our Earth's atmosphere extend to a distance greater than 500 kilometers, 300 miles, from the Earth's surface, but 1/2 of our atmosphere is within 5 kilometers, only 3 miles. This atmospheric blanket can be divided into layers of varying widths and characteristics. Most of our weather occurs in the troposphere, the atmospheric layer closest to the Earth's surface. Thus, atmospheric conditions in the troposphere are extremely important in crop production. The next layer is called the stratosphere and is the location of the ozone layer. Ozone protects plants and animals from the damaging effects of high-energy ultraviolet radiation emitted by the sun. Ozone absorbs ultraviolet radiation and reduces the amount reaching the Earth's surface. Unfortunately, man-made chemicals called chlorofluorocarbons, used in refrigerants, propellants in aerosol cans, and plastic manufacturing can destroy the ozone layer. Scientists have discovered ozone reductions of fluctuating size above the north and south poles, which may be linked to industrial emissions of chlorofluorocarbons. Because the estimated lifetime of chlorofluorocarbons in the atmosphere is 60 to 100 years, the greatest effect of these artificially made chemicals on our ozone layer is yet to be realized. Other atmospheric layers beyond the stratosphere include the mesosphere, the thermosphere, and exosphere. The ionosphere is an electrified region of ions and free electrons that crosses several atmospheric layers but is largely located in the thermosphere and is important in the transmission of radio waves. The next topic of study is the section on basic atmospheric relationships in the troposphere. You should now stop the VCR and study this section in your text. Then return to the VCR for further tutoring. It's important to realize that air is a gas which has compressibility. It can expand or contract according to temperature and pressure. Because of the Earth's gravitational pull, air has weight. The weight of atmospheric air on air near the Earth's surface is greater than on air at an altitude of 20,000 meters. Air molecules are squeezed closer together, and therefore air density and air pressure are greater for air at sea level than at higher elevations. As air becomes colder, it becomes more dense and sinks toward the Earth. Air that is being warmed becomes less dense and rises, similar to smoke-filled air rising from a campfire. Because water vapor, H2O, has a lower molecular weight, 18, than dry air, about 29, air with more water vapor in it is lighter than drier air and is more likely to rise. These basic relationships help explain how wind currents are formed, as well as understanding various weather changes. These principles can also help explain how cold pockets can form in depressional areas or river bottom areas. Cold air, being heavier than warm air, will settle to the bottom of depressions or river valley areas. Thus, the likelihood of a killing frost would be greater there than on the hilltops or hillsides. The next topic for study is the section on precipitation. You should now stop the VCR and study this section in your text. Then return to the VCR for further tutoring. The annual precipitation pattern in a region is important for crop selection and management. Cropping regions are defined by terms such as arid, semi-arid, and humid based on the total amount of precipitation per year and annual temperatures. Iowa precipitation ranges from about 25 inches per year in northwestern Iowa to 36 inches per year in southeastern Iowa. Therefore, Iowa would be classified as a subhumid to humid area. A very important aspect of precipitation is seasonal distribution. For example, northwest Iowa averages only 20 to 22 inches of precipitation per growing season, and southeast Iowa averages only 24 inches. This is only a 2 to 4 inch difference in precipitation during the time the crops really need the water, as compared to a 10-inch difference in precipitation for the total year for the two regions. Therefore, western Iowa usually has yields of corn and other summer annual crops approaching those of eastern Iowa. But because of the slightly lower precipitation in western Iowa, a more drought-tolerant crop, such as grain sorghum, is sometimes used as an alternative to corn. The next topic for study is the section on temperature. You should now stop the VCR and study this section in your text. Then return to the VCR for further tutoring. Temperature fluctuates not only from season to season, but from day to day and hour to hour. Temperatures vary within the soil and within the crop canopy. During the day, the Earth's surface is heated by the energy of solar radiation. The soil heats up, emitting heat radiation, which warms the air above it. At night, the soil is no longer receiving sunlight. The soil still emits heat and thus is cooling. The area receiving the greatest fluctuation in temperature is the area immediately above and immediately below the soil surface. At this area, daytime temperatures are very high and nighttime temperatures are very low. Temperatures within a 24-hour period vary less and become stable a short distance above and below the soil surface. Soil temperature variation is an important management factor. In cool spring conditions, soil nearer the surface, which may contain crop and or weed seeds, warms up faster and to a higher degree than soil at deeper depths. Crop and weed seed germination may be enhanced or inhibited by soil temperatures in the germinating zone. The cardinal minimum, optimum, and maximum temperatures for growth varies among crop species. Cold-tolerant species have lower optimum cardinal temperatures and thrive in cooler climates than cold-intolerant species. Temperate, cool-season crops, such as wheat or oats, are grown during the cooler part of the growing season than warm-season crops like maize, cotton, and soybean. The growing season of a region is determined by the number of days within the average dates of the first and last killing frosts of the year. The growing seasons are shorter at higher latitudes and elevations. This limits the range of crops that can be grown. For example, many cotton varieties require a growing season of at least 180 frost-free days. Southern states in the United States easily meet this requirement, but northern states do not. In most cases, crop development is hastened by warmer temperatures. The amount of heat received during the day can be calculated using the growing degree day formula. For predictive use with crops or insects, daily values are usually summed over specific time periods. For example, from silking to plant maturity for maize. By recording the growing degree days obtained during the season, one can more accurately predict corn growth than by simply counting the number of days since planting. For example, a 100-day maize variety indicates that 100 frost-free days are needed for the crop to mature. However, in reality, 110 days may be required if the growing season was unseasonably cool. The next topic for study is the section on humidity, water content of the air. You should now stop the VCR and study this section in your text. Then return to the VCR for further tutoring. Vapor pressure deficit, popularly called the drying power of the air, is the difference between the total amount of water the air could hold and what the air actually holds. Therefore, the greater the deficit, the greater the ability of the air to absorb moisture from crop plants, soils, and other sources of water. Warmer air can hold more water vapor than cooler air. Thus, hot air with low relative humidity has great capacity to dry out moist soils and plants. This may be good for drying freshly cut hay or reducing the moisture content of grain crops at harvest time. But high vapor pressure deficits can also be stressful to crop growth, causing drought stress or death if soil and plant moisture become severely depleted. The next section for study is the section on weather patterns. You should now stop the VCR and study this section in your text. Then return to the VCR for further tutoring. Regions of high and low air pressure can form in our atmosphere, causing air to move. In the northern hemisphere, winds blow clockwise and outward around a high-pressure cell, called an anticyclone. Winds blow counterclockwise and inward toward the center of a low-pressure cell, called a cyclone. Air is sinking in a high-pressure area, which usually produces clear skies and fair weather. The rising air in the low-pressure area cools and moisture is condensed, possibly producing clouds and precipitation. You can generally locate the direction from you of the high-pressure and low-pressure cells by noting the wind direction. If you stand with your back to the wind in the northern hemisphere, a low-pressure cell is somewhere to your left, and a high-pressure cell is somewhere to your right. Air masses are large bodies of air with fairly uniform characteristics over a horizontal direction. The four major air masses are continental polar, continental tropical, maritime polar, and maritime tropical. The origin of the air mass determines its characteristics. If the air mass forms over land, it is continental, and the air is relatively dry. Maritime air masses form over water, and the air is moist. Polar air masses form over polar climatic regions, and the air is cold. Tropical air masses form in tropical climates, and the air is warm. When different air masses meet each other, a zone of unstable weather, called a front, is formed at the boundary. A cold front occurs when a cold air mass replaces a warm air mass. The heavier cold air mass wedges underneath the lighter warm air, forcing it aloft at a relatively steep gradient. Thunderstorms, producing heavy showers with gusty winds, often result from cold fronts. Warm fronts occur when a warm air mass replaces cold air. The lighter warm air rides up and over the heavier cold air, producing a long, gentle frontal slope. Light rain or moderate showers and overcast skies for a wide area often result. Occluded fronts have characteristics of both warm and cold fronts. Occluded fronts occur when a faster-moving cold front overtakes a slower-moving warm front, lifting the warm front and the warm air mass off the ground. Oftentimes, cool, drizzly weather results. Weather patterns are also influenced by surface features, such as mountains and large bodies of water. Regions on the eastern, which is the leeward or downwind side of the Rocky Mountains, are characteristically dry due to drier descending air that flows down the mountain slope. Large lakes, such as the Great Lakes in the U.S., moderate temperatures, allowing more cold-sensitive crops to be grown on the leeward or downwind side. The next topic for study is the section on climatic change. You should now stop the VCR and study this section in your text. Then return to the VCR for further tutoring. It is generally understood that farmers frequently change the microclimate for crops by management practices such as irrigation, planting earlier or later in the season, leaving crop residues on the soil surface, or using windbreaks. However, as scientists study and learn more about the climate, it's becoming increasingly evident that human activity can influence climate on a macro or global scale. Sulfur emissions from industrial plants can result in acid rain, which can damage or destroy crops and forests. Existing vegetation can also be destroyed by deforestation. Overuse or misuse of semi-arid lands can result in desertification. A wide-scale loss of existing vegetation can alter the gaseous balance of our atmosphere and thus influence our global climate. Artificially induced changes causing an atmospheric greenhouse effect are of major concern. Solar radiation from the sun passes relatively easily through our atmosphere, but different atmospheric gases, called greenhouse gases, absorb and re-emit heat radiation back to the Earth. This is termed the atmospheric greenhouse effect and results in a warming of our troposphere. Carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons are greenhouse gases that have measurably increased in recent years because of human activity. Burning of fossil fuels in vehicles and industrial plants, burning forests, and producing man-made chlorofluorocarbons for aerosol propellants, air conditioners, and refrigeration have all contributed to increased levels of atmospheric greenhouse gases and the fear of global warming. Scientists continue to study and debate the effects of increased artificial emissions of greenhouse gases due to human activity. Some predict increased global warming with major effects on crop production regions and the problems associated with melting glaciers and ice caps. Others feel that there is not enough evidence to distinguish artificial from natural trends in global warming. However, most scientists would agree that human activity does influence factors that potentially can change climate on a global scale. Therefore, it's important that individuals, industries, and countries do their part in recognizing and then avoiding or reducing the factors which impact our climate. This is the end of the chapter on climate. You should now be ready to try the self-evaluation test at the end of the chapter in your text.